think little bit some simple, just checking the basic deviation concept here. A ray of light strikes at the boundary separating two media at angle theta. Mu1 and mu2 are the refractive index of the media with mu2 greater than mu1. Okay, this is a denser, this is rarer. So what is that sine inverse of, what is the critical angle? We'll define it. Sine sine C will define. So this will be critical angle. We do define like this, no? Mu2 sine C is equal to mu1 sine of 90 degrees. Sine C equal to mu1 mu2, where C is equal to sine inverse of mu1 by mu2. Very simple. Just the idea of TIR is what we are just analyzing. Nothing big is there. So when the angle of incidence less than critical angle, so when the angle of incidence is less than critical angle, the ray will undergo refraction, will move from mu2 to mu1. What is the deviation? This is the deviation. It wanted to go straight, it got deviated here. Now it's asking what is that deviation will be. So this angle of incidence, we can take it. And what about this? This everything is angle of refraction. So now deviation equal to I minus R. Mu2 sin R equal to mu2 sin I equal to mu1 sin R. R is the angle of refraction. No, deviation will be
R minus I, sir, deviation.
R minus I, sorry, deviation. It's moving from denser to rarer, no? Yeah. This theta is the angle of incidence given for us. R minus theta. So that R is what we are going to replace here. R will be mu2 sine theta sine inverse of mu2 by mu1 sine theta minus theta. Mu1 by mu2. Mu2 sine theta should be equal to mu1 sine R. This I is what theta we took it. Or we should replace, no? Mu2 sine theta. Yeah, some correction is there. Okay, there is a deviation. Next again, maximum deviation, the path of ray for refraction at boundary. What do you mean by maximum deviation? Maximum deviation should be equal to when it grazes, when it goes for grazing emergence, then only the deviation is maximum, no? This deviation will be maximum. Oh no, deviation will be can be like this. When the angle of incidence greater than critical angle, then the deviation what we can put it to be maximum. This is a deviation. For refraction at the boundary, oh sorry, option B, refraction condition is put, not reflection. I think there is a maximum deviation. So deviation in this case will be pi by 2 minus angle of incidence. What is the angle of incidence? That will calculate here. Now in this case, mu2 sine theta equal to mu1 sine pi by 2. So theta will be mu1 by mu2. We will replace theta, no? Sine inverse of mu1 mu2. Substituting this. Okay, no? So this is about the maximum deviation. No. Option A, B. A we got it. Okay, this I'll make correction. Mu2 by mu1. AS BP. Maximum deviation the path of ray for reflection at the boundary. Reflection at the boundary means this is a data, no? We'll keep it here. This should be pi minus it actually the ray will undergo TIR here. 180 minus 2 theta. So the deviation will be 2 theta. So here mu2 sine theta. We should not equal to mu1 it is. Option C, you see that how I'm applying sine law, just greater than critical angle, just greater than or equal to critical angle. What is theta? Just take the critical angle equal to critical angle. Deviation in the path at grazing angle of incidence. The last one. Once again, very simplified way, just trying to revise all the TIR concept here. The question is just grazing incidence. The ray should emerge at critical angle. This will be 90 degrees critical angle. Should go on that side, no? Yeah. Sorry, this is 90. Mu2, mu1. What is the equation? We can write it. Deviation in the path mu2 sine 90 grazing incidence this one only. Mu2 sine 90 should be equal to mu1 . It will get into the other medium, no? If it is here, then as you keep on increase the angle, it should come from grazing angle of incidence, deviation in the path at grazing angle of incidence. This should be the 90. No, it should be the ray. This should be 90. The diagram should be like this. Mu1 sine 90 should be equal to mu2 sine c. Now what is the deviation? Deviation should be 90 minus, see that one, critical angle. Okay, this will be mu1 by mu2. Check once. I think the last one little bit we have to assume a situation there. Unmute and talk, no? The what you type, I may not be able to understand.
Sir,
Yeah.
sir, if we take mu2 sine 90 equal to mu2 sine c, we'll get option.
Grazing incident is telling. So you are not sending along the normal, no? This is a normal. For normal, you define with respect to normal. This is a boundary, no? The ray, what will happen, cannot go like this. Actually, it is like this is the incident ray. This should be the refracted ray, no? Principle of reversibility of light you applied.
Yes, sir.
So from there what happen? So or you can think like this also. If this is the critical angle, this will be the grazing emergence. So from principle of reversibility of light, you can bring it in this way. Same, no? Both are. I shown it in different way here.
Thank you, sir.
Or say this you may get confused. Option D, we have done so many problems. I think not analyzing. For critical angle, the ray will be like this, no? Okay, fine. Grazing. Now from principle of reversibility of light, from grazing incidence, the emergent angle should be critical angle. That only I am showing it in different way here. This will be much easier if you want. Okay, the reverse of this, you think it. For grazing incidence, the emergent ray should be critical angle. That I shown it in this way here. I
Sir?
should have explained from here. Yeah.
Sir, the critical angle can be very near to 90 degrees also, no, sir?
Oh, what you are talking? Hmm? Angle of incidence, you better say this is 90 degree. Critical angle, why very near to 90? It depends on mu1, mu2. I don't know what you're talking. Please think once. Sai Surya. Sai Surya, unmute.
Yes, sir. Now I understood, sir. Yes, sir.
You cannot think that undeviated. No, it is not in 90. It is 89.99.
Yes, sir. Yes.
We have done so many points, very important. Huh?
Yes, sir.
Yeah. So I think the small things, everyone, anybody will land in trouble. So have such small thinking also. That what happen in limited time we are supposed to analyze. You see that one. Everyone knows Sells law. Everyone knows critical angle. But even then you see like it took almost 7 minutes for us to analyze.